The cosmos is a silent, endless ocean of black. Most of us look up and see a beautiful, starry sky, but hidden within that beauty are forces of unimaginable power and mysteries that defy comprehension. Today, we are pulling back the curtain on 25 of the most terrifying and mind-bending phenomena in the universe, details that will fundamentally change how you see the void above. By the end of this journey, you will know the hidden dangers lurking in the dark and the cosmic truths that scientists are only beginning to grasp. We will confront invisible monsters drifting between stars and a mysterious force pulling our entire galaxy towards an unknown fate. When you look up at the night sky, what feeling does the infinite darkness stir in you? That beautiful, starry sky is not the serene picture we imagine. Drifting through the immense voids between galaxies are invisible monsters, completely untethered from any star system. These are rogue black holes. They begin their lives at the centers of galaxies, but during violent cosmic collisions, the immense gravitational forces can slingshot them out into the endless dark. Now imagine a gravitational pit so deep that not even light can escape, and it is moving. Silent and utterly dark, it travels through the interstellar medium, leaving no trail, emitting no light. A rogue black hole could drift for millions of years completely unseen. Its approach would be virtually undetectable until it was already within our cosmic neighborhood. The first sign of its presence would be the subtle warping of distant starlight, a phenomenon known as gravitational lensing, but by then it might be too late. The sheer gravitational pull of such an object could shred entire solar systems without warning, pulling planets from their orbits and swallowing them whole. Stars would be stretched into streams of superheated gas in a terrifying process called spaghettification. The most chilling part is the statistical probability. With millions of these dark wanderers estimated to be roaming our galaxy alone, the possibility that one could be on a silent, undetectable collision course with our solar system right now is a genuine, haunting cosmic fear. It is the ultimate unseen predator, a reminder that the greatest threats in the universe are the ones we cannot see coming. But that unseen gravitational predator is not the only invisible force at work on a galactic scale. Our entire Milky Way, along with thousands of other galaxies, is caught in a cosmic current, all being pulled towards a single, terrifying point in the void. Astronomers call this the Great Attractor. It is a gravitational anomaly of such immense power that it defies easy explanation, a focal point for a vast flow of galaxies across the universe. The problem is, we cannot see it directly. This monstrous source of gravity lies in the direction of the constellation Centaurus, a region of the sky obscured by the dense bulge of stars, gas, and dust at the very heart of our own galaxy. This area is so thick with material it is known as the zone of avoidance, because it effectively blinds our telescopes to the cosmic secrets hidden behind it. For decades, this was a profound and unsettling mystery. We could feel the pull, we could measure our galaxy's 600 km/s velocity towards it, but we had no idea what was doing the pulling. It was like being in a boat, dragged by an invisible current towards a waterfall we could not see. What could possibly possess enough mass to command the motion of countless galaxies? The sheer scale of the force required is almost incomprehensible, equivalent to the mass of tens of thousands of Milky Way galaxies all concentrated in one place. Using advanced X-ray and radio telescopes that can peer through the galactic clutter, we have begun to glimpse the structure of this region. We now know the Great Attractor is not the final destination, but rather a waypoint in an even larger and more powerful flow of galaxies towards an immense supercluster of galaxies called the Laniakea supercluster. Yet the fundamental question remains unanswered. What is the true, ultimate source of this colossal gravitational pull at the center of it all? The unsettling truth is that we are still being drawn towards an unknown heart of darkness, a cosmic secret waiting in the obscure depths of space. This terrifying cosmic current, pulling us towards an unknown destination, pales in comparison to a threat that could rewrite the very fabric of reality itself. Our universe seems stable and permanent, with laws of physics that are constant and reliable. But what if this stability is an illusion? A leading theory in physics suggests our cosmos might exist in a state known as a false vacuum. Think of it like a ball resting in a small dip on the side of a vast, steep hill. It seems stable for now, but it is not in its true, lowest energy state. The ball could be knocked into the deeper valley below. In our universe, this would be a transition to the true vacuum. If such an event were to occur, a single, microscopic bubble of this true vacuum could spontaneously form anywhere in space at any moment. The laws of physics inside this bubble would be completely different. The fundamental constants that allow for atoms, molecules, and life itself would be erased and rewritten. This bubble would then expand in all directions at the speed of light. There would be no warning, no way to see it coming. One moment, the universe exists as we know it. The next, an impenetrable wall of new physics is upon you, and everything you ever knew simply ceases to be. It would not be an explosion. It would be an instantaneous and total unmaking of existence, a wave of absolute nothingness that propagates across the cosmos, leaving a new, alien universe in its wake. The most chilling part is the trigger. It would not require a cosmic collision or a stellar explosion. It could be sparked by a random quantum fluctuation, an event with no cause, happening trillions of light years away or right here in our own solar system. The rules of the game could change before we even knew we were playing. This unmaking of reality is a threat from within the laws of physics, but the cosmos also wages a more visible, violent war. The serene image of a spiral galaxy is a cosmic lie. In truth, galaxies are predators. They engage in a brutal process known as galactic cannibalism, where larger galaxies gravitationally tear apart and consume their smaller neighbors. Our own Milky Way is a prime example of this celestial violence. It has a history littered with the remnants of galaxies it has already devoured, their stars now assimilated into our galactic halo. But the greatest feast is yet to come. In about 4.5 billion years, the Milky Way is destined to collide with its largest neighbor, the Andromeda Galaxy. This will not be a simple merger. It will be a chaotic, billion-year-long gravitational dance of destruction. As the two galaxies first approach, their immense gravitational fields will begin to pull each other apart. Long before the stars themselves collide, the delicate spiral structures will be shredded into great, streaming arcs of stars and gas. Our solar system will be caught in this cosmic turbulence. There is a very real chance that the gravitational forces could fling us out of the galactic disk entirely, ejecting our sun and its planets into the cold, dark intergalactic void. We would become a true orphan solar system, untethered from any galaxy, adrift in an endless sea of black. If we remain within the merging galaxies, the night sky would transform into a terrifying spectacle. Instead of a familiar band of Milky Way stars, the heavens would be filled with the brilliant, distorted core of Andromeda, as countless new stars are born from the colliding gas clouds. The two supermassive black holes at their centers will eventually spiral together, creating a single, monstrous engine. Ultimately, the violence will subside, leaving behind a single, giant elliptical galaxy, a bland and featureless testament to a cosmic battle fought and won. Our galactic home, as we know it, will be gone forever, consumed in an act of creation born from destruction. While galactic cannibalism tears entire star systems from their homes, some stars are violently ejected alone into the abyss. These are hypervelocity stars, and they are the universe's ultimate celestial cannonballs. Born within the chaotic cores of galaxies, they are flung out by the unimaginable gravitational forces of supermassive black holes. A star that ventures too close to such a black hole can be caught in a slingshot maneuver. accelerating it to speeds exceeding 1,000,000 miles per hour. This is not a gentle nudge into a new orbit. It is a catastrophic expulsion, a sentence of eternal exile into the intergalactic void. Imagine our own sun, but stripped of all its planets and launched on a one-way trip through the cold, empty darkness between galaxies. That is the fate of a hypervelocity star. It becomes a solitary wanderer, a sun-sized projectile on a trajectory set billions of years ago. The sheer kinetic energy such an object carries is almost beyond calculation. If one of these stellar bullets were to pass anywhere near a solar system like our own, the consequences would be apocalyptic. Its gravitational influence alone would be enough to destabilize the delicate orbital dance of planets, sending worlds careening into each other or flinging them out into the frozen deep. A direct hit is statistically almost impossible given the vast emptiness of space, but a near miss would be more than enough to spell the end for any life in the system. The star's intense radiation and gravitational pull would shred planetary atmospheres and trigger global extinction events. These stars are a reminder that the violence of the cosmos is not confined to galaxies. It can be launched directly at us, a silent, sun-bright missile traveling at impossible speeds through the dark. The violence of stellar ejections leaves stars adrift in an immense darkness, but that darkness itself can be the true mystery. In the constellation of Boötes, astronomers have found a hole in the universe. This is the Boötes Void, a spherical region of space so staggeringly empty it defies all expectation. Stretching for 330 million light-years across, this cosmic desert contains almost no galaxies. To grasp that scale, if you were to place our Milky Way at its center, the nearest wall of this cavern would be farther away than any galaxy we can see with the naked eye. In a universe filled with billions of galaxies, this void is a profound and unsettling nothingness. The question of how such a vacuum formed is one of astronomy's greatest puzzles. One theory suggests it could be the result of a merger of many smaller voids, like soap bubbles combining into one gigantic cavity. Another, more speculative idea is that it was carved out by an advanced civilization on a scale we cannot fathom, though most scientists look for natural causes. The sheer isolation of this place is terrifying. Any hypothetical planet inside the void would have a night sky almost completely black, with just a handful of faint, lonely galaxies visible. There would be no cosmic landmarks, no nearby neighbors, just an endless, starless frontier. It is a chilling reminder that the universe is not uniformly filled with light and life, but is instead a patchwork where vast, empty deserts stretch between the archipelagos of galaxies. We exist in one of those bright islands, looking out across a gulf of nothing so vast it could swallow our entire local group of galaxies without a trace. Even the death of a star is not always final. Some stellar corpses refuse to stay dead, reanimating in a final, catastrophic blaze of power. These are the zombie stars, and their resurrection is one of the most violent events in the cosmos. The most common type is born from a white dwarf, the dense, Earth-sized core of a sun-like star that has burned out. Left alone, it would slowly cool into a black cinder over billions of years. But if it has a companion star in a binary system, a far more terrifying fate awaits. The white dwarf's immense gravity begins to steal hydrogen and helium from its neighbor, siphoning this fresh fuel onto its own surface. Over thousands of years, the stolen material accumulates, compressing under the dwarf's fierce gravity. The temperature and pressure at its base climb to unimaginable levels. Eventually, they cross a critical threshold, and in a single, unstoppable instant, the entire white dwarf reignites in a runaway thermonuclear explosion. This is a Type Ia supernova, a detonation so perfectly calibrated by physics that it always releases the same amount of energy. The star does not just die again, it is completely obliterated, leaving behind nothing but an expanding cloud of incandescent gas and stardust. For a few weeks, this single zombie star can outshine an entire galaxy. There is another, even more bizarre path to reanimation. Imagine the super-dense core of a dead neutron star, a city-sized object with the mass of our Sun. If this stellar corpse wanders too close to a black hole, the black hole's gravity can violently squeeze and spin it. This immense friction and pressure can, in theory, temporarily reignite nuclear fusion in the dead core, causing it to shine once more with tremendous intensity before it is inevitably shredded and consumed. These events are a stark reminder that in the universe, death is not always a quiet end. It can be a prelude to an even more spectacular and destructive final act, a ghostly echo of stellar life that ends in absolute annihilation. This profound silence from the cosmos presents a question so unsettling it has its own name. The Fermi Paradox asks a simple thing: where is everybody? Given the sheer number of planets in our galaxy alone, the universe should be teeming with life, a bustling interstellar community. Yet when we listen, we hear only an eerie, unbroken silence. This quiet is more terrifying than any signal we could possibly receive. It implies something is terribly wrong. One explanation is the Great Filter hypothesis. This idea suggests that the evolution of intelligent life faces a barrier, a single, nearly impossible challenge that almost every civilization fails to overcome. This filter could lie in our past, a step so difficult that we are miraculously one of the first to achieve it. Perhaps the jump from simple single-celled life to complex multicellular organisms is astronomically rare. That would make our very existence a cosmic fluke. The far more terrifying possibility is that the Great Filter awaits us in our future. It could be that all technological civilizations, upon reaching a certain point, inevitably discover the means of their own destruction. This could be nuclear war, a runaway artificial intelligence, a bioengineered plague, or a technology we have not yet even conceived. The silence of the universe in this scenario is a graveyard. It is the evidence that countless other civilizations have already risen, only to flicker out and vanish before they could ever make their presence known across the stars. We are left wondering if we are listening to the quiet that comes after a mass extinction event on a galactic scale. Are we, too, destined to become just another silent entry in this cosmic ledger? One more reason for the next emerging species to gaze at the stars and wonder why they are so alone. The silence of a dead universe is terrifying, but the scream of a dying star can be lethal across thousands of light years. Among the most volatile stellar corpses are magnetars, a type of neutron star that takes the concept of a magnetic field to an apocalyptic extreme. A typical magnetar possesses a magnetic field so powerful it defies human comprehension. To put it in perspective, the magnetic field of a common refrigerator magnet is about 1 Gauss. Earth's own protective magnetic field measures less than 1 Gauss. A neutron star can have a field of 1 trillion Gauss, but a magnetar, that is something else entirely. Its magnetic field can reach 1,000 trillion Gauss. If a magnetar were located as far away as the Moon, its magnetic field would effortlessly strip the data from every credit card on Earth. But that is just a parlor trick compared to its real destructive power. These stars are under immense strain from their own magnetism, and like a tightly wound spring, they occasionally snap. This event is known as a starquake. The crust of the neutron star, a material denser than any on Earth, fractures and shifts, releasing a cataclysmic burst of energy. This is not a simple flash of light. It is a focused eruption of gamma rays and X-rays of almost unimaginable intensity. In December 2004, a magnetar 50,000 light-years away released a starquake. For 1/5 of a second, it released more energy than our Sun has emitted in the last 250,000 years. It actually compressed Earth's upper atmosphere and partially ionized it, disrupting long-range radio communications. And that was from clear across the galaxy. Now, imagine if one of these starquakes occurred much, much closer. A magnetar located just a few thousand light-years away, pointing its deadly beam directly at us, would deliver a radiation blast equivalent to 1,000 solar flares hitting Earth all at once. The first wave of gamma rays and X-rays would not burn the ground, but it would devastate our planet's shield, the ozone layer. In an instant, this protective blanket that filters the sun's most harmful ultraviolet radiation would be chemically broken down and stripped away. The result would be a planetary sterilization event. The surface of Earth would be bathed in lethal levels of ultraviolet radiation from our own sun. Phytoplankton in the oceans, the base of the marine food web, would die off. Crops on land would fail. Ecosystems would collapse, leading to a mass extinction that would make the dinosaur-killing asteroid look like a minor inconvenience. The terrifying reality is that we have narrowly missed such events in the past. In 1094, Chinese astronomers recorded a guest star in the constellation Taurus, bright enough to be seen in broad daylight for weeks. We now know this was the supernova that created the Crab Nebula, and at its heart lies a pulsar, a rapidly spinning neutron star. Had that stellar corpse been a magnetar, and had its pole been aligned with Earth, the course of history would have been irrevocably altered. We live in a cosmic shooting gallery, where the twitch of a dead star tens of thousands of light-years away holds the power to end life on our world. Even the immense structure of our galactic supercluster is not our final destination, for we are caught in a movement on a scale so vast it defies all logic. Astronomers have discovered a phenomenon known as dark flow, a ghostly current in the cosmos. Huge clusters of galaxies, numbering in the thousands, are all streaming in the same direction at incredible speeds, like leaves caught in a river with no visible source. This motion is separate from the universe's expansion, a distinct and mysterious drift. The terrifying part is what lies at the end of this current. The pull is coming from a single point far beyond the edge of our observable universe, from a place we can never see or reach. All the matter and energy we know about, all the galaxies and dark matter within our cosmic horizon, cannot account for this motion. Something immense, something completely outside our realm of existence, is tugging on us. This points to a spine-chilling possibility. Our universe, the entire expanse of everything we call reality, might be just one bubble in an infinite multiverse. The dark flow could be the gravitational influence of another universe, another bubble of space-time, brushing up against our own. Or it could be the pull of a cosmic structure so colossally large, it exists beyond the visible boundary of our Big Bang. We are like fish in a pond, suddenly realizing the entire pond is sliding downhill, pulled by a force from a world we cannot comprehend. This is not just a mystery, it is a fundamental challenge to our understanding of reality. We are not merely expanding, we are being drawn, and the destination is a terrifying unknown from which no light can ever reach us. This ghostly pull from beyond the universe is a danger on a cosmic scale, but a far more immediate and human-made terror is taking shape just overhead. The space around our planet is no longer a pristine void. It is a crowded junkyard, and we are on the verge of triggering a catastrophe of our own making. It is called the Kessler Syndrome, a chain reaction of destruction that could slam shut the door to space for generations. Imagine a single collision, perhaps between a defunct satellite and a discarded rocket body, both traveling at 17,000 miles per hour. The impact does not just create two pieces of junk. It generates thousands. Each fragment, from a bolt to a shard of solar panel, becomes a new high-velocity projectile. These fragments then cross the orbits of other satellites, causing more collisions, which in turn create even more debris. This is the cascade. Each collision fuels the next, exponentially increasing the cloud of shrapnel. Within a matter of years or even months, a critical threshold is crossed. The region of low Earth orbit becomes a maelstrom of whirling metal. The debris cloud would be so dense and fast-moving that any spacecraft or satellite venturing into it would be instantly shredded. This would not be a slow process. It would be a violent, rapid transformation of our near-space environment into an impassable kill zone. The consequences are almost too dire to contemplate. First, our space-based infrastructure would be annihilated. The International Space Station would be evacuated and eventually destroyed. Global positioning systems, weather monitoring, worldwide communications, and even financial networks that rely on satellite timing would fail. We would be thrust back decades technologically, blind and disconnected. The most terrifying long-term effect, however, is the potential for orbital imprisonment. The shell of debris could become so thick that no rocket could safely pass through it. The fragments would be traveling too fast to be effectively tracked or avoided. A launch would become a suicidal gamble, with the spacecraft facing almost certain destruction. We would be trapped on Earth, looking up at a sky we could no longer reach, surrounded by the glittering fragments of our own ambition. This is not science fiction. The ingredients for this disaster are already in place, with tens of thousands of tracked objects and hundreds of millions of smaller, untrackable pieces already in orbit. We are playing a high-stakes game of celestial dominoes, and one wrong move could set off a chain reaction that changes the future of humanity forever. The orbital prison we are building for ourselves is a danger of our own making, but the galaxy holds far older and more natural threats, worlds that have become orphans. Rogue planets are the ultimate nomads, cast out from their home solar systems to wander the eternal cold of interstellar space. These are not merely asteroids or comets, but full-fledged worlds, some as large as Jupiter, drifting alone in the absolute black. They are invisible, dark, and astonishingly common. Some estimates suggest there could be billions, even trillions of them in our galaxy, potentially outnumbering stars by a vast margin. Their surfaces are a vision of hell-frozen solid. With no host star to warm them, temperatures plunge to just a few degrees above absolute zero. Any atmosphere they once possessed would have long since collapsed into icy deposits on the ground, creating landscapes of frozen nitrogen and methane harder than granite. Yet, paradoxically, some of these frozen worlds might harbor secrets beneath their icy crusts. Tidal forces from their planet's core, or residual heat from its formation, could maintain vast, global subsurface oceans of liquid water, sealed away under a shell of ice dozens of miles thick. In the absolute darkness and crushing pressure, could some form of exotic life persist, entirely unaware of a universe beyond its frozen sky? The truly unsettling possibility, however, is their movement. These planets are not stationary. They travel on their own lonely paths through the galaxy, governed only by the weak pull of distant stars. The chance of a direct collision with our solar system is infinitesimally small, but a close pass is a genuine statistical possibility. If a Jupiter-sized rogue planet were to wander into the outer reaches of our solar system, its gravitational influence would be catastrophic. It would act like a colossal gravitational wrecking ball, perturbing the delicate orbits of every object it passed. The serene clockwork of our planetary system would be thrown into chaos. Comets from the Oort Cloud would be sent raining inward, bombarding the inner planets. Earth itself could be knocked into a new, lethal orbit, either flung out into the cold or dragged closer to the sun. The approach of such a world would be stealthy, its dark form giving no warning until its gravity had already begun to unravel the fabric of our cosmic home. We would be helpless against a force of nature that had been traveling in silence for billions of years, a ghost from the galactic dark coming to call. The silent approach of a rogue planet is a threat from the cold dark, but the most certain end for our world comes from the heart of our own solar system. Our sun, the source of all life and warmth, has an expiration date. In roughly 5 billion years, it will begin a transformation that will utterly annihilate the inner solar system. This is not a quiet fading, but a violent, bloated death. As the sun exhausts the hydrogen fuel in its core, it will start burning helium, causing its core to contract. and its outer layers to expand at a terrifying rate. It will swell into a red giant, a monstrous, pulsating ball of fire. Its outer atmosphere will creep outward, first swallowing the planet Mercury in a silent, fiery embrace. Venus, the scorching sister planet, will be next, its surface and atmosphere vaporized into the Sun's growing envelope. Then, the expanding edge will reach for Earth. Long before our planet is physically engulfed, its fate will be sealed. The Sun's increasing luminosity will begin to bake the world. The oceans will not simply evaporate, they will boil. The skies will turn into a thick, steam-filled oven, trapping heat and driving surface temperatures to over 2,000 degrees Fahrenheit, hot enough to melt lead. The very rocks will begin to glow a dull red. The continents will warp and liquefy into vast plains of magma. The atmosphere will be stripped away by the intense solar radiation, scattering its components into the void. Finally, the orbit of Earth itself will decay, dragging our molten, unrecognizable world into the Sun's photosphere. For a brief, horrifying moment, our planet will be a distinct, superheated streak within the stellar furnace before it is completely dissolved, its atoms scattered to become part of the dying star. The cataclysm will end with the Sun throwing off its outer layers, creating a beautiful but deadly planetary nebula. All that will remain of our vibrant, living world is a faint, enriched trace within that cloud of gas, while the Sun's core will cool into a dense, Earth-sized white dwarf, a diamond-like cinder glowing with residual heat for trillions of years. It is a future written into the fundamental laws of physics, a guaranteed apocalypse set on a timer of 5 billion years, a reminder that even the star that gives us life holds the blueprint for our ultimate destruction. That certain apocalypse written in the stars makes our search for other intelligences feel profoundly urgent. And for one brief moment in 1977, we thought we might have found an answer. The Big Ear radio telescope at Ohio State University was silently scanning the sky, part of the long-running search for extraterrestrial intelligence, or SETI. On August 15th, a narrowband signal, a sharp spike at exactly the frequency of the hydrogen line, a frequency scientists predicted other civilizations might use, slammed into the receiver. It was so powerful that it maxed out the equipment. The next day, astronomer Jerry Amon was reviewing the computer printout, a long scroll of letters and numbers representing signal strength. His eyes scanned across the sequence and he saw it. A string of characters so remarkable he circled them in red pen and wrote one word in the margin: wow. The signal, designated 6EQUJ5, lasted for a full 72 seconds, the exact time it took for the Big Ear to fixate on that single point in the constellation Sagittarius. It came from a region of space with no known stars or planets. It was a perfect candidate for an artificial transmission, a beacon from the void. And then it was gone. Despite decades of repeated, targeted searches of that same spot in the sky, the signal has never been heard again. Its one-time, unexplained nature is the source of its deep and abiding terror. What could it have been? The most haunting possibility is that it was a message, a one-time burst directed at us or simply sweeping past our solar system like a lighthouse beam in the cosmic dark. Perhaps it was a final, desperate transmission from a civilization on the brink of extinction, a last shout into the silence before they were wiped out by a natural disaster or their own technology. We might have intercepted the dying words of an entire world, a ghost signal from a species that is now just cosmic dust. Or perhaps the beacon is still active, and its beam is so focused that it simply has not swept over Earth again in the 40-plus years we have been listening. We caught a single, fleeting whisper, and the next one will not come for another 10,000 years. The wow signal remains the most compelling and frustrating mystery in the history of SETI. It is a tantalizing piece of evidence that we are not alone, paired with the chilling silence that followed. A reminder that the cosmos might be full of voices, but their conversations are brief, isolated, and separated by gulfs of time so vast we may never hear a single sentence. That profound silence after the wow signal leaves us listening intently to the dark. Yet the greatest danger to our world may not be a message from the void, but a silent bombardment from our own cosmic backyard. Encasing our entire solar system like a vast, invisible shell is the Oort Cloud, a theoretical realm of frozen remnants from the system's birth. This is not a close ring like the asteroid belt, but a staggering spherical cloud of icy planetesimals, a trillion or more frozen bodies, beginning roughly 2,000 times farther from the Sun than Earth and stretching halfway to the nearest star. We cannot see it directly, for these objects are too small and too dark, but its gravitational influence is the only explanation for the long-period comets that occasionally plunge into our view from every direction. Within this deep freeze, these primordial chunks of ice and rock orbit in a state of near-perpetual stillness, a celestial storage unit holding the building blocks of our planetary system. Their existence is a constant, subtle threat, for their delicate orbits are easily disturbed. The gravity of a star passing even a light year or two away, a cosmic near miss that happens every few 100,000 years, is enough to act as a gravitational paddle. It gives a tiny nudge to thousands of these icy bodies, altering their paths just enough to send them falling sunward. This is the source of a comet shower, a rain of icy missiles launched from the darkest reaches of our own solar system. As these objects fall inward, the Sun's heat transforms them. Frozen gases vaporize, creating magnificent, glowing tails that can stretch for millions of miles. But the beauty is a deadly illusion. The solid nucleus at the heart of a comet, often many miles across, is a planet killer. The impact of such an object carries energy far greater than all the nuclear weapons on Earth combined. It would not just create a crater, it would blast the atmosphere, trigger global firestorms, and cast the planet into a long, dark winter. The Oort Cloud is a loaded gun pointed at the inner solar system, and the trigger is pulled every time a star wanders a little too close through the galactic night. We are living in the crosshairs of a celestial mechanism set in motion 4.5 billion years ago. A reminder that the most immediate existential threats do not come from alien galaxies, but from the frozen, forgotten fringe of our own home. The frozen sentinels of the Oort Cloud are a threat on a planetary scale, but the ultimate end could come from a force woven into the very fabric of space. This is the Big Rip, a cosmological model for the final destruction of everything that exists. It hinges on the nature of dark energy, the mysterious force driving the accelerated expansion of the universe. In this terrifying scenario, dark energy is not a constant, gentle push. Instead, it grows stronger over time, becoming infinitely powerful. As the expansion of space accelerates, it does not just move galaxies apart. It begins to overwhelm the fundamental forces that hold the universe together. First, the cosmic scaffolding fails. The gravitational glue that binds entire galaxy clusters together is no match for the raging expansion. Galaxies are torn from one another, flung into an ever-widening emptiness where no other islands of stars are visible. Next, the violence moves inward. Within a galaxy, the expansion of space itself overpowers the gravity holding individual solar systems to the galactic core. Stars are ripped from their orbits, sent flying alone into the void. Then, the destruction comes for our home. The same expansion that tears galaxies apart will eventually infiltrate our own solar system. The Sun's gravitational hold on Earth and the other planets will be broken. Our world would be flung away from its life-giving star, a frozen, dark rock on a one-way trip to nowhere. But the horror does not stop at the planetary level. As the dark energy continues to intensify, it will attack the very bonds that hold matter together. The force that keeps you and the ground beneath your feet intact will fail. In the final, fleeting moments, Earth itself is torn apart. Mountains, rocks, and molecules are all ripped to shreds. Finally, in the last fraction of a second, the expansion becomes infinite. It severs the nuclear forces holding atoms together. electrons are torn from their nuclei. Protons and neutrons are shredded into quarks. Every single piece of matter in the universe, from the largest star to the smallest particle, is utterly and completely disassembled. The universe does not end with a bang or a whimper, but with a silent, ultimate disintegration into a thin, cold haze of disconnected subatomic particles, forever unable to interact again. The timeline for this apocalypse is staggeringly long, perhaps trillions of years in the future, but the principle is what chills the soul. The same force that today pushes galaxies apart could one day turn its unimaginable power against the very building blocks of reality, leaving a cosmos where not even atoms can exist. Even our most carefully planned voyages into the void can be haunted by the unknown. As the Pioneer 10 and Pioneer 11 spacecraft sailed out of the solar system, becoming the first human-made objects to embark on an endless journey into interstellar space, they carried with them a small, persistent mystery. Back on Earth, scientists tracking their trajectories noticed something deeply unsettling. The probes were slowing down, not from the gentle tug of distant planets or the faint pressure of solar radiation, but by a tiny, constant, and completely unexplained deceleration. It was as if an invisible hand was gently but insistently pulling them back. This was the Pioneer anomaly, a deviation so small it was barely measurable, yet for decades it stubbornly defied every conventional explanation. It was a ghost in the machine of celestial mechanics, a faint whisper that the laws of physics as we knew them might be subtly, terrifyingly incomplete. Was it some unknown property of gravity itself, behaving differently over immense interstellar distances than it does within our cozy solar neighborhood? Or perhaps it was the drag from clouds of invisible, exotic dark matter, a mysterious substance that permeates the galaxy, subtly brushing against our tiny emissaries. The most unnerving possibility was that we were seeing the first hints of an entirely new physical force, one that only reveals its presence on the grandest of scales. For years, this tiny anomaly was a profound puzzle, a reminder that our understanding of the cosmos, built with such confidence, might have fundamental cracks. The mystery was so compelling that it eventually spurred a massive, years-long effort to find a mundane explanation, digging through decades-old engineering data and telemetry records. The solution, when it finally came, was almost anticlimactic. The slight deceleration was traced to an effect called thermal recoil force. The spacecraft's radioactive power sources generated heat, and as that heat radiated away from the probes unevenly, it provided a tiny, constant push, like a very faint rocket engine, slowing them down just enough to account for the anomaly. Yet the legacy of the Pioneer anomaly remains. It stands as a stark warning of our own ignorance. For decades, the best scientific minds in the world were convinced they were seeing new physics, only to discover a subtle engineering effect they had overlooked. It proves that when we venture into the deep, we must be prepared for the unsettling truth that the universe may hold secrets we have not even begun to suspect, and that sometimes the most terrifying discoveries are the ones that reveal how much we still have to learn. Even the echo of creation itself is not perfectly smooth. When we look at the most ancient light in the universe, the cosmic microwave background radiation that is the faded afterglow of the Big Bang, we see a nearly uniform canvas of tiny temperature variations. But in one particular region of the sky, in the constellation Eridanus, there is a blemish, a patch of cold so vast and so profound it should not exist. This is the cold spot, a cosmic bruise stretching over 1.8 billion light-years. It is not merely a little cooler than its surroundings. Its temperature deficit is so significant that standard cosmology struggles to explain it. This is not a void in the modern universe, though one does partially overlap with it. The sheer scale of the cold region defies the standard processes of the early universe. It is an anomaly, a ghost in the machine of our cosmic models. One of the most spine-chilling theories to explain it is that we are looking at the scar of a collision with another universe. In the multiverse hypothesis, our universe is just one bubble in a frothing sea of infinite cosmic realities. If another bubble universe brushed against our own in the first instance of inflation, the energy transfer between these two separate realities could have left a permanent imprint, a cold spot in the primordial light, like a bruise on the skin of our cosmos. It would be evidence of something fundamentally unseeable and untouchable, a parallel reality making its presence known only through a fossilized imprint in our most ancient light. Another, equally unsettling theory posits that the cold spot is a signature of a cosmic texture, a flaw in the fabric of spacetime itself, a knot that formed as the universe cooled from its initial superheated state. Whether it is a collision with another reality or a tear in the fabric of our own, the cold spot stands as a haunting reminder that the deepest foundations of our universe may be marked by violent, ancient events we are only beginning to decipher. That unsettling chill from the cosmic cold spot is a remnant of the ancient universe, but some relics from that violent past are far from dormant. Lurking at the hearts of the most distant galaxies are cosmic blowtorches of unimaginable power, known as quasars. These are not stars, but the intensely luminous cores of galaxies, powered by a voracious supermassive black hole. As colossal amounts of gas, dust, and even entire stars spiral into the black hole's accretion disk, the material is heated to millions of degrees by friction and magnetic forces, glowing with a brilliance that can outshine a trillion suns. This energy is then focused and ejected from the poles of the black hole in two opposing, narrow beams of radiation and particles, moving at near light speed. These jets are the true menace. They are the most powerful and efficient engines in the known universe, capable of carving through intergalactic space for millions of light years. If one of these beams were to be pointed directly at our solar system, the consequences would be apocalyptic, even from a staggering distance. The first sign would be a silent flash of gamma rays and X-rays of an intensity far beyond any Magnetar starquake. This initial radiation blast would act like a planetary-scale microwave oven, instantly cooking our atmosphere. It would rip apart the ozone layer, leaving Earth's surface exposed to the full, lethal fury of our own sun's ultraviolet radiation. The sky would glow with lethal auroras as high-energy particles rained down, triggering widespread mutations and destroying the electronic infrastructure of modern civilization. The beam would essentially sterilize the planet from light years away, a death sentence delivered at the speed of light with no possibility of defense. The most chilling part of this threat is its ghostly nature. Because light takes time to travel, every quasar we observe is a glimpse into the deep past. The brilliant beacon we see in a telescope today is a snapshot of an event that occurred billions of years ago, when the universe was young, and such monsters were more common. The galaxy that hosted that quasar may have long since settled down, its central black hole now quiet and dark. We have no way of knowing if a similar cataclysm is already on its way to us from a nearby galaxy, its lethal beam traveling through the dark for eons, its source now invisible and silent. We are looking at snapshots of cosmic violence from a bygone era, never knowing if one of those ancient beams is still en route, carrying our extinction within its light. The universe holds structures so geometrically perfect they seem to defy the natural chaos of cosmic creation. Drifting 6,500 light-years away in the constellation, Monoceros is one such object, a nebula so bizarre it has been named the Red Rectangle. Through our most powerful telescopes, it does not appear as a typical cloud of gas and dust. Instead, it reveals a stark, X-shaped structure, a series of concentric, rectangular rungs that look less like a stellar nursery and more like a piece of otherworldly architecture. This is not an artist's impression or a trick of the light. It is a real, observed object, and its existence challenges everything we know about how nebulae form. Most planetary nebulae are created when a dying, sun-like star ejects its outer layers, creating often spherical or bipolar clouds. The red rectangle, however, features these impossibly straight sides and sharp corners. The leading theory suggests that the central star is actually a close binary system, two stars locked in a tight orbital dance. As they age, they both expel gas and dust, but their mutual orbits may be funneling this ejected material into two conical outflows. From our vantage point, looking directly down the barrel of these cones, we see the intersecting lines that create the X shape. Yet, this explanation still feels incomplete. The perfection of the geometry, the precise, ladder-like rungs, suggests a level of order that gravity and stellar winds alone may not fully account for. This has led to more speculative and far more haunting possibilities. Could we be looking at the signature of an advanced technology, a cosmic-scale engineering project so vast it shapes the very structure of a nebula? While scientists rightly favor natural causes, the red rectangle forces us to confront a profound question. When we see something in the cosmos that looks intelligently designed, are we witnessing the limits of our own understanding? Or are we catching a fleeting, terrifying glimpse of a universe that is not as empty as it seems? That unsettling silence, the one that followed the wow signal, might not be a sign of emptiness, but of a universe hiding in plain sight. This terrifying possibility is known as the dark forest hypothesis, and it offers a chilling answer to the Fermi Paradox. Imagine the entire cosmos as a vast, pitch-black forest. You are alone in the dark, and you know there are other hunters hidden among the trees. You cannot see them, and you have no way of knowing if they are friendly or hostile. In this scenario, the most rational thing you can do is stay absolutely silent. Any sound you make, any campfire you light, could attract something far more powerful and dangerous than you. Now, scale that up to a galactic level. Every civilization is a hunter in this dark forest. They know the universe is old, and that any other civilization they encounter could be millions of years more advanced. The technological gap could be so vast that a more advanced species might see a younger one as we see ants, as something to be ignored, or simply wiped out as a matter of course. The logic is brutally simple. You cannot afford to take the risk that a newly discovered civilization is benevolent. The potential cost of being wrong is total annihilation. Therefore, the only safe strategy is to remain completely hidden. You do not broadcast your location. You listen intently, but you never, ever reply. Some civilizations might even take this a step further, becoming what are called preemptive strikers. Upon detecting the faintest whisper of another intelligent species, their first and only action is to launch a weapon to eliminate that potential threat before it can ever become a problem. This could be why the universe is so quiet. It is not a graveyard of dead civilizations. It is a forest full of living, breathing intelligences, all holding their breath, all terrified of giving away their position. The silence we hear is not emptiness. It is the sound of universal paranoia, a collective decision to hide from a danger that may or may not be there. In a dark forest, the most terrifying thing you can hear is not a growl, but the sound of your own voice echoing back at you, because you have just told every hunter exactly where you are. This philosophy of cosmic silence finds its chilling parallel in the physical reality of worlds so extreme they defy any hope for life. One such world is a glittering monument to cosmic excess, a planet known as 55 Cancri. Orbiting dangerously close to its host star, this is not a treasure trove waiting to be mined, but a vision of hell rendered in precious stone. Astronomers believe its internal composition, rich in carbon, has been subjected to immense pressure and heat from its star, crystallizing a significant portion of the planet into diamond. Imagine a world with a crust of graphite, the material in your pencil, stretching across a core of solid diamond. Yet this unimaginable wealth exists under conditions of pure torment. The planet is tidally locked, meaning one side is in perpetual, scorching daylight while the other is in eternal night. Surface temperatures on the dayside soar to over 4,000 degrees Fahrenheit, hot enough to melt iron and vaporize rock. The very rocks on its surface may not even be solid, but exist in a superheated, molten state. Some theories suggest that the extreme temperature difference between the two hemispheres could generate supersonic winds, whipping the atmosphere into a frenzy and potentially causing it to rain liquid rock, droplets of molten silica falling from a diamond sky. This is a world of brutal contradiction, a jewel forged in a stellar furnace so intense it could never be touched, a paradise of wealth existing within a landscape of absolute annihilation. It stands as a stark warning that the universe is capable of creating wonders that are utterly, terrifyingly hostile to life as we know it. Even the most fundamental pillars of our cosmic knowledge are beginning to crack under the strain of new data. A quiet but profound crisis is brewing in cosmology, centered on a single, critical number, the Hubble constant. This figure represents the rate at which our universe is expanding, a value we thought we could pin down with precision. But we now have two highly precise, completely independent ways of measuring it, and they stubbornly refuse to agree. This growing discrepancy is known as the Hubble tension, and it is not a minor accounting error. It is a fundamental conflict that threatens to unravel our entire understanding of the cosmos. One method involves looking at the nearby universe. We observe stars and galaxies, measure their distances and how fast they are moving away from us, and calculate the expansion rate directly. This is like measuring the speed of a car by watching it drive down a street. The other method uses the afterglow of the Big Bang itself, the cosmic microwave background. By meticulously mapping the faint imperfections in this ancient light, we can work backwards to predict how fast the universe should be expanding today. This is like calculating how fast that car should be going based on the power of its engine and the incline of the road it started on. The terrifying problem is this: both methods are executed with incredible care and precision, yet they give us two different answers for the universe's current expansion speed. The difference is not large, but it is statistically significant and it will not go away. It is as if you calculated a car's speed to be 55 miles per hour by looking at its engine, but when you look out the window, you see it is clearly going 65. Something is very wrong with our understanding of the vehicle. This tension points to a chilling possibility. Our standard model of cosmology, the very bedrock of modern astrophysics, might be incomplete or fundamentally flawed. This model relies on specific ingredients: dark energy, dark matter, and ordinary matter, all behaving in a very particular way to produce the universe we see. The Hubble tension strongly suggests that one of these ingredients is not what we think it is. Perhaps dark energy is not a constant force but is evolving, growing stronger or weaker over time. Maybe dark matter has properties we have not yet discovered, interacting with itself or with other forces in strange ways. Or in the most radical scenario, we might need entirely new physics, a new type of particle or field that we have never detected, to explain the discrepancy. The implications are staggering. The ultimate fate of the universe, whether it will tear itself apart in a big rip or eventually collapse back on itself, hinges on the precise nature of this expansion. If we cannot even agree on how fast it is expanding now, how can we possibly predict its final destiny? The Hubble tension is a ghost in the equations of cosmology, a silent alarm bell telling us that the universe still holds profound and potentially terrifying secrets about its own composition and our place within it. Our entire solar system is a passenger on a voyage so immense its timescales dwarf human history. We are not stationary within the Milky Way. Our Sun, along with all its planets, is hurtling at over 500,000 miles per hour around the galactic core, tracing a vast, elliptical path through the spiral arms. A single complete circuit, one galactic year, takes our solar system roughly 225 to 250 million years. The last time Earth occupied this precise point in its galactic orbit, the planet was unrecognizable. The supercontinent Pangaea was just beginning to fracture. The first dinosaurs were emerging, small and insignificant creatures in a world dominated by ancient reptiles and giant ferns. That single galactic revolution encompasses the entire reign of the dinosaurs, their dominance and their sudden extinction, followed by the rise of mammals, and the entire span of human evolution from the first primates to the civilization we know today. All of recorded human history, every empire, every discovery, every life that has ever been lived, fits into a sliver of time too small to even register on this cosmic clock. It is a humbling and terrifying perspective. Our sun has completed this journey only about 20 times since its birth. In its lifetime, it will complete fewer than 20 more before it dies. We are temporary residents on a spaceship making a slow, grand tour of a galaxy whose true scale we can barely comprehend. This cosmic calendar forces a chilling question. As we complete our next infinitesimal fraction of this orbit, what will become of our fleeting civilization? Will we leave any mark that could possibly last even a single galactic year? The grand clockwork of our galactic orbit feels undeniably real. The very ground beneath our feet, a testament to a tangible universe. But what if that reality is the most sophisticated illusion ever created? This brings us to our final terrifying concept, the simulation hypothesis, a theory suggesting that everything we perceive, from the farthest quasar to the feeling of warmth on your skin, might be nothing more than lines of code in an inconceivably advanced simulation. The argument begins with a simple logical progression. If a civilization ever reaches a level of technological maturity, it would likely possess the computing power to run vast, detailed simulations of its own history, or of entirely fictional universes. Given enough time and resources, such a civilization might not run just one simulation, but billions, each populated with conscious, simulated beings who believe their world is real. Now, if that is true, the number of simulated realities would vastly outnumber the one base reality. Therefore, statistically, the odds are overwhelmingly high that we are not in the original reality, but living inside one of the countless simulations. The evidence, some argue, is hidden in the very fabric of our universe. Why do we live in a reality that appears quantized, where time, space, and energy come in discrete, indivisible chunks, much like the pixels on a screen or the clock cycles of a processor? The finite speed of light could be a processing limit, a way to prevent the simulation from overloading by rendering only what is being observed. Even the bizarre rules of quantum mechanics, where particles exist in a haze of probability until measured, could be seen as a resource-saving technique, a form of lazy loading where the universe only fully renders something when a conscious observer is looking at it. The implications of this being true are existentially terrifying. It means our deepest joys, our most profound sorrows, our entire history and future, could be nothing more than a data set in a project for some post-human graduate student. Our struggles for meaning, our search for purpose, could be utterly meaningless in the grand scheme of the programmers. What happens if the simulation is turned off, or worse, if it crashes? And what of the entities running it? Would they be gods or mere technicians? Would they even care about the simulated lives within their creation? Or would they see us as we see characters in a video game, to be reset or deleted on a whim? The simulation hypothesis does not offer comforting answers. It forces us to question the very nature of our existence, leaving us to wonder if we are the creators, the created, or simply ghosts in a cosmic machine. We have journeyed through 25 of the cosmos's most profound and unsettling secrets, from rogue black holes drifting unseen in the galactic dark to the ghostly pull of the Great Attractor. We have faced the potential unmaking of reality in a false vacuum decay, and watched as galaxies engage in brutal acts of cannibalism. The sky has revealed hypervelocity stars, cosmic cannonballs ejected from their homes, and the chilling, empty expanse of the Boötes Void. We have witnessed the resurrected fury of zombie stars and grappled with the deafening silence of the Fermi Paradox. The universe has shown us its weapons, from magnetars capable of sterilizing planets to the self-made prison of the Kessler Syndrome. We have considered orphaned rogue planets and the certain, fiery death of our own sun. We listened for a message in the wow signal and found only a fleeting, haunting whisper. We stand in the crosshairs of the Oort Cloud and contemplated an ultimate end in the Big Rip. We tracked the Pioneer anomaly, a tiny ghost in the machine, and pondered the cosmic bruise of the cold spot. The lethal beams of quasars and the impossible geometry of the red rectangle reminded us of both immense power and profound mystery. We hid in a dark forest and witnessed a world of diamond and fire. The Hubble tension revealed cracks in our fundamental understanding, and our galactic orbit placed our entire civilization in a humbling, new perspective. Finally, we questioned the very nature of our existence within a possible simulation. This journey reveals a universe that is far more than a beautiful tapestry of stars. It is a realm of immense, impersonal forces and deep, enduring mysteries, a cosmos where awe and terror are two sides of the same coin. We want to know which of these cosmic truths unsettled you the most. Was it the silent approach of a dark wanderer, or the philosophical horror of the dark forest? Share your thoughts in the comments below. And if your curiosity about the cosmos is as vast as the void itself, subscribe for more deep dives into the universe's greatest secrets.